Okay, this video is designed to help you with the law of cosines. The law of cosines, in addition to the law of sines, can help you solve any non-right or right triangle for that matter, such as the triangle is given to you here. This is an SAS scenario. Unfortunately, it would not work to try to start with the law of sines right now, because the only angle that we don't know its opposite side. And remember, you need a pair of angle and side in order to start the law of sines. But the law of cosines involves three angles and any of the, or three sides, sorry, and any of the angles. Therefore, if we know two of the sides and the angle in between, we can say that a squared plus b squared minus 2ab cosine of the angle between, or c, will help you find side c. Well, right now we know sides c and b. So we're going to change our lettering around a little bit. We're going to say that a, or a squared, will be equal to c squared plus b squared minus 2cb cosine of a. And if we set that up, you'll notice that 10 squared plus 15 squared minus 2 times 10 times 15 cosine of 115 is that exact setup. Now we pop that all in the calculator. You notice the entire right side has no variables. And then don't forget that that's equal to a squared, so take the square root, and we can find side A. Side A is 21.255. Now that I do know an angle on its opposite side, I can move on to start to find one of the angles, such as, I'm just going to pick angle C to go looking for. So angle C is opposite side C. And in that case, that means I can set up a law of sines. I now know that 115 degrees, don't forget your degree symbol, is compared to 21.255. And by the way, keep that on your calculator. If you have it on there with more decimal places, you'll be more accurate. But as far as our writing it down goes, accurate to at least 3. But that's equal to the sine of c over 10. Do a little bit of cross multiplying, and then take the inverse sine, and we'll quickly find out that angle C is 25.239 degrees. And then finally, if we want to find angle B, remember that all three angles have to add up 180 degrees. Therefore, 180 minus 115, again, don't forget your degree symbols, especially if you're converting things on the calculator, plus that 25.239 degrees, and you'll be equal to 39.761 degrees. Now that's how you can use the law of cosines in a straightforward fashion. Now, if we jump forwards, the law of cosines also works for a side-side-side scenario, or a triangle where you might know all three sides, and you're going to start off by looking for some angles. Now, in order to avoid the problem of the two triangle scenario with the law of sines, the best thing to always do is try to find your largest angle first. So what I'm going to do is I'm going to go after angle C first. Right? Again, in order to avoid that two triangle issue, if you ever wanted to swap to the law of sines, find the largest angle first. Or you can just do the law of cosines the entire time in the scenario that we're about to do, which is probably what I'll go ahead and do. So, given our triangle, we're going to adjust our law of cosines a little bit. Notice that I've taken my a squared and my b squared and we've brought them over to the other side, and I've divided by my 2ab. That negative on the 2ab, it used to be subtraction when it was on the other side of my cosine. That negative got thrown up top and made that into a positive a squared, a positive b squared, and a minus c squared. Again, feel free to ask your teacher about how to adjust the law of cosines, but now that we have the formula, we can just go use it. So if we wanted to find angle C, right away we can start typing in. Well, sides A and B, since I'm looking for angle C, those are the two sides around angle C. So 3 squared plus 9 squared minus the opposite side, so minus 11 squared over 2ab. When you type that carefully into your calculator, and then take the inverse cosine, notice that we're at the cosine of C, we can find out that that's 125.035 degrees. Then, again, you can either switch to the law of sines. Now that you know the obtuse angle, the other two angles have to come out acute, which, remember, the law of sines, even in the two triangle scenario, will always find you that acute angle first. But, probably easier, is just to type in those same side lengths again, only moving them around a little bit. So you'll notice here, because I'm subtracting the 9 squared, and I've made my 3 and my 11, the sides around my angle, while 9 squared makes me think that I'm solving for angle A. So this will be the measure of angle A down here. And then you can do the same thing again. Since I'm subtracting the 3, that makes it, I'm finding angle B. I'm subtracting off my opposite side squared. And notice again, I've made those two sides around it on both the top and the bottom. Note the division symbol of my typing. Now you'll notice a great way to check your answer is to add up all three angles and make sure you really did everything right. So 125 plus that 42 plus 12, and make sure that you're actually getting 180 degrees. But in that case, you should have the right answers. Hope that helps you with the law of cosines. Again, it's great for the SAS scenario. It's also great for side, side, side. Just depends on if you want to use the regular law of cosines from the previous screen or the adjusted law of cosines that we see here. Good luck and have fun.